Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And today what we're going to do is we're going to actually calculate out a wavetable and use that wavetable to develop a sine tone. Okay, so this is going to be a little bit different from what you might see on the Juice tutorial website where they do a sine wave synthesizer. The reason is that because in the Juice tutorial, the way that they calculate out the sine wave function is they do it by basically calculating out the whole sine wave by the frequency, and they're doing this 44,100 times a second. And there's actually a more computationally efficient way to do this, and they actually say this in the tutorial. So I thought, why don't we just skip directly to wavetable synthesis and use that to make our sine tone. Okay, so that's what we're going to do today. So what we need to do is we're just going to create a new project. And once again, we're doing an audio application. I'm gonna briefly rehash over some of the things that we did last tutorial. Not too much, but just enough so we kind of remember what we're doing here. So we're going into Audio Programmer. We're just going to call this Wavetable Sine. Okay. And we're just going to create that, open it up in Xcode. So I'm assuming that you have some audio programming knowledge, but if you don't, I'm going to try to explain some of these concepts the best that I can, and hopefully I'll be clear in my explanations. Okay, so here we are. We're back in the audio app component, okay, which has given us these three functions. Okay, we've got prepare to play, which just is kind of like our setup function. Just gives us our where we can declare any sort of initial variables that we need for our app. Okay, then we got get next audio block, which is our audio callback function, and where we're going to do all of our audio processing. Then we have release resources, where we can release any resources that we need to get rid of once we close the app. Okay, so what we're going to do first is we're just going to kind of go in here into get next audio block and create our buffer where we can access the buffer and iterate through it, writing these numerical values so they'll go out to the speaker. Okay, so we'll do that using a for loop. We'll call it sample. Okay, sample is less than. Okay, we're going to access our buffer now. Okay, and it's a pointer, so we need to use the arrow operator. Actually, we could just do this, num samples, okay, and plus sample. Okay, so now we need to create our write positions for the buffer. Now, in the last tutorial, I think because we were doing just random numbers going into the left and right speaker, we were able to just create another for loop that iterated through the left and the right channel, writing random values there, and we didn't get any problems. Now, when I was practicing doing this tutorial a little bit earlier, I found that I was getting buzzing from when I was trying to do the sine wave the same way. I was getting buzzing, and I think the reason I was getting buzzing was because I wasn't treating the left and the right hand channel separately. So what I need to do is I need to basically create two pointers, and those are going to allow me to access the left and the right hand speaker differently. Now, this is the best way that I found to do it. If there's somebody that's a little bit more experienced that happens to know a better way to handle this, then step on forward and let us know what the better way is. Okay, cool. So we're just going to call this flip pointer const. I'm just going to call this left speaker. Okay, and then this is going to be buffer to fill dot buffer. So we're just accessing the buffer. Now we're going to get the right pointer, so we just need to access the right pointer so we can write values into it. Okay. Now the channel number is going to be 0. That's just going to be our left-hand speaker. And the sample index is going to be buffer to fill dot start sample. Okay, so we're just going to the first index in our buffer to prepare to write that to the left-hand speaker. So now we're just going to do the same thing for our right-hand speaker. Speaker buffer to fill that buffer, get our right pointer, and it's channel number 1, and we're just gonna go to the same place. So what we're doing is we're just taking this buffer and we're writing it to the left and right hand speaker at the same time. Okay. So cool. So that's what we got there. Okay. So now let's go and start thinking about creating our wavetable. Okay. So as I said before, what we're going to do is we're going to create one cycle of the sine function. Okay. And we're going to hold it in, we're going to hold these values in an array. And then what we're going to do is we're going to use another array to access what value we are within the sine function. And what that's going to do is give us the value that we need to go out to the speakers and give us the sound that we want. Okay. So we're going to create an array of floats. Okay, because we're going to be holding, what we're doing is we're actually holding the value of where the sine wave is at a certain place in the cycle. Okay, we're just going to call this wavetable. Okay, now I'm going to point something out to you here that might be helpful. Now, there's an actual array class within Juice, okay? So this might be a little bit confusing at first, but when you think array in Juice, it's not like a standard array in C++, okay? Because as you probably know, a standard array in C++, you can't push into it, you can't find out the size of it. But this array, when you think array in Juice, the array here is more like, the structure is more like a vector. Okay, so you can push into it, you can access certain values, delete elements off of it, add elements to it, so on and so forth. So array in Juice is like vector in C++, sort of. Okay, so we've created an array, a Juice array, where we're going to hold this, these values for this sine wave function. Okay. Now we need to decide how big that we want this array to be. Okay. So we're just going to call this a double. Call it wavetable size. Okay. Then we need to create a frequency for when we're actually going to put this sine wave out to the speakers. What frequency do we want it to be? Okay. Now we need to create a phase. Okay. The phase is just the position within that one cycle of the wavetable. Okay, that we're at. So if we're at the very beginning, so think of phase as just the position. Like, so if we're at index 0, then our phase would probably be 0 at that point. Okay, and then we got to create an increment. Okay, so the increment. So the way that this is going to work is we've created one cycle of the sine wave. Then we go to the phase. Let's say the phase is 0. We're at the very beginning. Okay. Once it's written the first value, then we need to know how much we need to move over before we access the next value. Okay. And that's going to be our increment. So we need to come up with a formula there that defines how much we're moving over each time we're accessing a new value in the wavetable to write to our speakers. Okay, so let's go ahead and instantiate these values within prepare to play. Okay, so frequency, we're just going to make 440 hertz, just middle A. Phase, we're just going to start out at 0. Okay, then we come to this question of increment. Okay, how much are we going to increment by? Okay, and I want us to think about this rather than just kind of throwing the formula out to you. We're just going to think about this for a moment. Okay, so we have a frequency, right? So what we need to do is we need to define how. So if we had one cycle of the sine wave, okay, and the sine wave was one cycle, we would say that cycle went around once in 2 pi radians. Okay, so I hope you understand this. If not, you may need to go back to some of the audio, the DSP basics that I've done in some of my other courses. Okay, so one cycle of the sine tone completes within 2 pi radians. Okay, 360 degrees. So normally, if we were calculating out the sine function within here in C++, and we just wanted to calculate that the way, just if we were just doing that just normally, okay, we would say that we need 2 pi, that we need the sine wave to complete 2 pi within 44,100 hertz, or if we wanted a 1 hertz sine tone, or we needed if we needed to complete 440 times in a second, then we would multiply the frequency times 2 pi divided by 44,100 hertz. Okay, this is a little bit different in that we have a wavetable size, which we haven't defined yet, and we need, instead of the wavetable completing in 2 pi, we need it to complete in whatever that wavetable size we define to be. Okay, so we're going to do wavetable size, okay, divided by the sample rate, which is 44,100 hertz. Okay, so we'll define our wavetable size. We could just start with 1,024 samples. Okay, so that is going to be a 1,024 value long array that we're going to write the one cycle of the sine wave function into. Okay, and we're going to do that right here. And the way we're going to do that is using a for loop. Okay, so int I equals 0, I is less than the wavetable size, I plus plus. Okay, now what we need to do is we need to insert values into the array. Okay, so we need to find our add our pushback function if you've worked with vectors before. So I believe it's insert. Okay, so here we go. So we have insert, where we insert the value at a given position. The position is going to be our index, which is going to be I, and then our parameter type, our new element, is going to be the sine function. Okay, so let's go ahead and do that. So we're going to go wavetable, which is the name of our array, and then we're going to go wavetable dot insert. Okay, and then I, which is going to be our index. Then this parameter type is going to be our actual sine function. Okay, the function. So we're going to calculate one cycle of this sine wave. Okay, so we're going to go sine, then we're going to go 2 times pi. Okay, pi is written double pi. a little bit confusing because double pi does not mean 2 pi, okay, which is what I thought it meant at first. So I thought, like, well, why is it doing 6.28 whatever? No, double pi actually means pi cast as a double float, okay? So we got double pi times I divided by the sample, oh no, wavetable size. Okay. So do you see what I did there? So we're just calculating one sine function and we're putting it into the into this array, and the array is the wavetable size. Okay, so this is just one cycle of a sine wave. Okay. So we've now computed the sine wave. So now we just need to get it actually into the speakers. Okay. So what we need to do is we need to go left speaker. Okay. At the sample index. Okay. So this is just the buffer. Equals. Is it sine? No. Let me think about this. So we just need the array table. Okay, now this is a little bit tricky. Okay, so we need to basically use the phase. Okay, the phase starts off at 0, and then we're going to use the phase and the increment. The increment's going to be how much we need the phase to move over to calculate the next value that we're reading into to push into the speaker. Okay, now the phase is going to be a float. Okay, but we want it to be an int, not a float. Okay, so we need to cast this. Okay, and I'll explain again why in just a moment. Why is it giving me 2 array? That's a bit weird. Oh no. What am I doing here? So wavetable array. Oh, I'm just getting confused. Okay, cool. Okay, so as I said before, the phase is going to be a float. Okay, the phase is showing us, okay, where in this sine function do I need to grab my value? Okay, now you know that an index needs to be an int, not a float. So that's why I'm casting it here as an int. Okay. So I think that's it. So I'm just going to multiply this. I'm going to create a variable called amplitude. Amplitude. Okay, and I'm just going to define. I'm going to go float. And maybe I should make it a double. Amplitude. Okay, and then I'm just going to define the amplitude as like 0.25 so it doesn't blow our ears out. Okay, so that's just to make this. So these are going to be values going from +1 to -1. Okay, and I'm just multiplying that by 0.25 just to make them a little bit softer. Okay, so we're going to do the same thing for the right speaker. Wave table. Okay, int phase times the amplitude. So the thing that I'm doing with the left-hand speaker, I'm just copying it to the right-hand speaker. Okay, cool. So if I did this now, it would probably just like click, because what it would do is it would give us 1024 values. Okay, so go from 0 to 1024, but then it wouldn't know what it needs to do after it reaches 1024. Okay, so we need a way for this function to wrap around when it gets to the end of the wavetable. Okay, so the way that we're going to do this is we're going to do phase equals. Okay, so So once it's calculated the value that it needs at that particular index, or I don't want to say calculate. Calculate's a bad word. Once it's accessed the value of the sine function at that particular index, it needs to know how far it needs to move over to access the next value of the sine wave we've calculated. Okay, so we've got phase plus increment. Okay, so that's the first part of it. Okay, so we calculate, so we access the value that it is at a certain index, and then we increment it by the formula that we calculated earlier. Okay, but now we've got a problem. What happens when we get to the end of the end of the array? Okay, when we need to wrap around. The way that we're going to do that is using a modular function. Okay, now since it's a float, since these numbers are doubles, we need to use rather than using a regular modulo function, we need to use fmod. Okay, so we need to go fmod, which is a modulo for a double. Okay, and then our first element is going to be the phase and the increment. And the second one is going to be our wavetable size. Okay. So what that's going to do is that's going to, if the element gets over, if the position of our index gets over our wavetable size, then the modulo function is going to allow us to wrap around to where we go back to the beginning of the wave again. Okay, and calculate that over. And then phase plus increment, I think I've explained that enough already. So hopefully this will work. Okay, so I'm just going to compile now. It's going to take a minute. Just looking over here, seeing if I'm missing anything. I think that's everything. Okay. As I've said before, if there's a way, especially on this part, if there's a way that you know to do this more efficiently, drop me a comment or a message, and I'd love to know. So, still thinking. There we go. So there's our wave at 440 hertz. Okay, so so I hope this was helpful, and what I'll do is. I'll put the Juice code. I'll put this code in the comments below, just so you can check it out. If you have any questions, or if you feel that something needs to be explained a little bit better, just drop me a line or leave a comment below. And I hope you like the tutorial, and I will see you next time.